For exactly 9 months, you were a water-dwelling creature. You didn't use your lungs, and you didn't breathe air. In fact, if you tried to take a breath under those conditions, you would drown. Instead, as this schematic illustrates, oxygenated blood bypassed the lungs entirely. The placenta functioned as a biological superhighway, pumping oxygen directly into your bloodstream. Because they weren't required, your lungs remained collapsed and fluid-filled, biologically useless during pregnancy. But the moment of birth changes everything. The umbilical cord is clamped and severed, instantly cutting off that external oxygen supply. Without that continuous flow, carbon dioxide and acid levels in the baby's blood begin to spike toward a toxic threshold. Specialized sensors in the arteries called chemoreceptors detect this chemical buildup. They fire an immediate distress signal straight to the brainstem. This signal initiates a strict 10-second countdown. To survive, the newborn must now perform a physical action it has never attempted before. It has to take its very first breath. The brainstem reacts to the chemical spike by firing a massive electrical jolt down to the diaphragm, the sheet of muscle sitting just below the lungs. The diaphragm muscle violently spasms and yanks downward with absolute maximum force, desperately attempting to expand the chest. But the expansion is blocked. The baby's lungs are glued shut by the fluid inside them. Inside the lungs, millions of tiny air sacs, alveoli, are deflated, stuck together by intense surface tension. To force them open, a newborn must generate 15 times normal breathing pressure. Fortunately, a chemical called surfactant acts like detergent, breaking these bonds. The resistance gives way. The fluid is driven out, and millions of alveoli violently snap open to pull in air for the very first time. While the lungs are now inflated, the transition isn't over. That oxygen is only useful if the heart immediately reconfigures its own anatomy to transport it. Before birth, the fetal heart was designed with physical bypasses to prevent blood from being wasted on the fluid-filled lungs. This diagram shows two specific anatomical shunts, the foramen ovale and the ductus arteriosus. These valves allowed blood to route directly through the heart while avoiding the pulmonary system. But as that first breath fills the lungs, the sudden presence of fresh oxygen triggers a mechanical chain reaction. The blood vessels surrounding the lungs suddenly widen, drawing a massive volume of blood into the pulmonary circuit for the very first time. This redirection of blood causes an immediate and massive shift in pressure between the chambers of the heart. This pressure change forces the heart's internal valves to violently slam shut. In less than a second, the prenatal shunts are permanently sealed tight. The sealing of these valves permanently alters the circulatory path, ending the body's reliance on the prenatal system. Oxygen now floods the newly established circuit, moving from the lungs to the heart and out to the rest of the body. You can actually see this internal shift on the outside. The newborn's skin rapidly changes, flushing from a pale, oxygen-deprived blue to a vibrant pink. The 10-second countdown is over. The transition from a submerged state to an atmospheric one is complete. This is the most violent, dangerous, and precisely coordinated sequence of physical events a human body will ever experience. Every person alive today successfully navigated this exact biological gauntlet. It is just one of many complex transitions we undergo before we even take our first steps. If you want to see how two babies manage to grow in the same womb at the same time without competing for these resources, click the video on your screen right now. I'll see you there.